Okay, so what you are going to notice in class is that we are going to start using a lot of terms that you probably have heard before, but we want to make sure that you have the correct definition of them. As you are learning these terms, please, please, please do not forget them because I don't have time to go over them over and over again through the semester. We'll keep adding to the basic information I am going to give you today. So we are going to start with a framework for understanding and classifying matter. And it's very important because it's the foundation of everything we do in chemistry. So it all starts with matter. So matter is anything that has mass and volume, but it's a fundamental term that we use because everything is matter. So matter is anything that has mass and takes up space. It's what everything in the universe is made of. It's what everything around you is made of. Is what you are made of. You are made of matter. One thing that is important to notice is that for it to be matter, it needs to have mass, it needs to have volume. Therefore, it needs to have density. If it doesn't have one of those two, it cannot be classified as matter. So if I say fire, is fire matter? What do you think? It's either yes or no. I heard a yes. I see a lot of people saying no. The correct answer is no, because fire is energy. Energy doesn't occupy space, therefore cannot be matter. Okay, is air matter? Air is matter because it does occupy space. You don't see it, but it's there. Air has a specific volume. It has a specific mass. So it is matter. Now we can also say that we have a substance. A substance is a very specific type of matter because it has a very uniform and definite composition. So for example, water is a substance, but a salad is not, because salad is made of different things. It has to have a very specific defined composition. So one thing can be classified as substance. And you'll see these two words come up over and over through the semester. Okay, moving on. So matter has mass, but we tend to confuse mass and weight being the same thing. They are not, because mass is the amount of matter in the object. It doesn't change regardless of the location. It doesn't matter where you're located. You will always have the same mass. So the mass that you have on Earth will be the same mass in the moon. It will be the same mass in Saturn, and so on. It doesn't change. Weight does change because weight depends on gravity and the pull of gravity has on you. So your weight on the moon is less than the weight on the Earth because there's less pull of gravity in the moon than there is on Earth. So mass and weight differ. One is affected by gravity, the other one is not. And almost everything we do in class will refer to mass in here because those masses do not change. Weight, you deal a lot when you go to physics, and we don't talk about physics in this class. And I should mention, because it's an intro class, you'll see and you'll hear me say a lot, okay, this is as far as I'm going to take it, but you also understand there's more layers to this, that once you take Chem 1, Chem 2 organic chemistry will give you the better picture of what's going on. So matter has mass. We don't talk about weight when we refer to matter. Okay, you'll see that we now have matter, and matter we're going to start dividing it in different things. And we start by dividing matter based on their states. So we have three common states. You've seen this before. You know this because you've been taught this your whole life. So we have solid, liquid, and gas. Those are the only three we are going to take a look at. There's another one called plasma. We don't look into plasma here. What you see is that as you move from left to right, the shape changes because solids have a definite shape, but once you get to a liquid, that shape starts getting more indefinite, and gases have no shape. Gases take the shape of wherever they are located in. Then for volume, again, solids have volume, liquids have volume, gases, the volume is in, indefinite, meaning that it changes because gases are unique. We'll spend a lot of time on gases at the end of the semester, so we'll leave it with these basic ideas of what each one is. Then solids have low energy because they're not moving, they're only vibrating. As you move to the liquid and the gas, you start gaining energy. That's why those particles start moving more. Solids have higher density than liquid and gases. So from left to right, density decreases. Gases are very light. Just imagine yourself walking and hitting gas particles. It will not be a fun thing. So as you move, you push the gas particles to the side. That's why the shape changes and the volume can change. And then gases have the highest speed because those particles are constantly moving. The liquid, they're moving a little bit, and solid is just vibrating. So properties of the state of matter change as you add energy to them. And there's a reason why solids are solids, liquids are liquids, and gases are gases. That has to do with forces that we are not going to take a look at in this class, or Chem 1. That's a Chem 2 topic. But no, there's more to the story than just what I am giving you. Okay, so not only you need to know about the state of matter, you have to know how to call those changes. And we are going to concentrate ourselves to the ones here on the yellow. Let's not worry about plasma. But solid to liquid, that's melting. Liquid to solid, that's freezing. And I know you heard these terms before, so let's make sure we know exactly what's happening. Liquid to gas, that's vaporization, and then gas to liquid, that's condensation. Those four you should already know. It's only the last two that are kind of new to you, but one of them you have, well, both of them you should know about, you just don't realize you do. So solid to gas, that's sublimation. Where have you seen that? You go to a party, you go to a concert, you see that white smoke. That's dry ice going from solid to gas. It doesn't go to a liquid. That's how they get that gas effect using dry ice. Then gas to solid, that's deposition. You are depositing something into another thing. That's how they do metal plating in the industry. That's more of an industry thing. It doesn't happen spontaneously. You need to be in a controlled environment for deposition to happen because it requires a lot of energy. So matter is made of three different states, but it's also defined based on the changes that happen in them. And we'll go over changes soon enough again to make sure that we explain that a little bit more. Okay. So we classify matter based in its properties. The properties of matter are the ones that describe matter. So we have states, now we have properties. So when you describe matter, you're looking at how it looks, how hard it is, if it shines, if it's a crystal, and so on. So you describe based on how it looks. And those properties can be physical or chemical. If they are physical, they're describing what you see. Okay, so I have a whiteboard, I have a black marker, there's a green and a red marker on the front of the room. Those are physical properties because they're describing how they look. So physical properties are describing as is, meaning what you see, there's no change. So color, solubility, odor, density, melting point, boiling point, all those describe something about that matter. So if you have water, water is a liquid, it's a crystal, it's a clear liquid. It's wet, it boils at 100 degrees Celsius, it solidifies at 0 degrees Celsius. All those describe something about water. So they are considered physical properties. For it to be a chemical property, they had to undergo some type of chemical change. So they had to change from something to something else. So it's a transformation. So when you're burning, when it's flammable, when it tarnishes, when it reacts with acid, all those are chemical properties. So if it sounds like a chemical reaction is happening, that means it is chemical property. If it is just describing how it looks, it is a physical property. If I ever go too fast for you, please let me know. I can speak super fast. And if I ever start speaking Spanish, please let me know. I've done it in the past and nobody said anything. Okay, so let's do a couple of practice here. So rubidium has a white silver luster when cut. Will that be physical or chemical? It will be physical. Titanium burns in air. That will be chemical. Gold is unaffected by acids. That will be chemical. Not being affected or being affected is a chemical thing. Bromine freezes at minus 15.15 degrees Celsius. That will be physical. Copper weathers to a green patina. That will be chemical. That's how copper rusts. Chlorine is a yellow-green gas. That will be physical. Hydrogen is explosive in oxygen. That will be chemical. Chromium dissolved in hydrochloric acid. That will be chemical. This word dissolving can be misleading. In the context of dissolving in hydrochloric acid because you are messing with an acid. You know something is going to happen, a chemical reaction is going to happen, so that will be considered chemical. If you have salt dissolving in water, that will be physical because the salt is still salt, the water will still be water. They can be separated. So be careful with that word. Gallium is a soft white metal. That will be physical. So this material will be tested just like this. I'll give you statements and you classify them based on what they are. Okay, let's move on. Okay, so now we have changes. Changes go hand in hand with properties. If you know properties, you know changes. Changes are physical or chemical. That's why I'm saying if you know properties, you know changes because they go hand in hand. So physical changes are your changes in state of matter, basically. Chemical changes is because a transformation happens. Some chemical reaction is happening. That's why it says reactions on top. That's how your reactions happen. So evaporation, boiling, melting, freezing, sublimation, deposition, all those are physical changes. And those are pretty much the only ones you'll have to know. Chemical changes, paper burning, that will be a chemical change because it was paper. It's going to be ashes at the end. Rusting, digestion in your body, all those are chemical. If it implies a chemical reaction, it is chemical. If it implies a change in state of matter, it is physical. Okay, so they go hand in hand. Now, matter can also be classified as a substance, and we already know what that meant. So we're gonna say the type of matter, and that type could be pure or a mixture. We'll look at each one shortly. And that classification of type is based on what type of substance it is. Because remember, a substance has to have a very definite proportion or property. If that changes, the type changes. So we start by saying that matter can be classified as a pure substance, and the pure substances can be elements or compounds. Elements because it's just one type of atom. Let me one type of atom. All the elements are in the periodic table, so if you can find it in the periodic table, it's most likely element. It's the smallest you can divide matter. Again, it's made of only one type of atom, like C for carbon, N for nitrogen. And when we start looking at the periodic table, you'll notice there's symbols in there. We'll go more into that later on, but if it is one letter, it's always an uppercase. If it is two letters for that element, the first one has to be uppercase, the second one has to be lowercase. For example, helium, He. The H is upper, the E is lower. So that's as far as I'll take it for now. If you start combining those elements and combine, let's say, the hydrogen with the oxygen to make water, you no longer have an element, you have a compound. Compounds are made of two or more atoms bonded together. And that's the big difference. So let me, are those two things the same thing? No, one is an element, the other one is a compound. CO, because it's upper lower, that implies an element, that's cobalt. C and O, that's carbon monoxide. Two different things. Very important when you start dealing with chemicals, so you don't get hurt because you don't know what you're dealing with. So again, pure matter can be a pure substance because it can either be an element or a compound. Element if it is only one atom, compound if it is more than two atoms bonded together. It has to be two different atoms because I can have that, and that's still sulfur. Has 8 atoms of sulfur, but it's still sulfur. Compounds, two different atoms. If it is the same atom, even though it's multiples of them, it's still the element. Okay, so then the other type of matter. Matter can be a pure substance or it could be a mixture. A mixture because you have different things mixed together. So it's not uniform throughout, like a salad. You have your lettuce, you have your tomatoes, you have your peppers, and so on. Mixtures can be pulled apart without losing the properties of each of these components. So you can take all the lettuce out, and it's still lettuce. You can take all the peppers out, there's still peppers. Now, the thing is that when you mix things, they can be either homogeneous or heterogeneous. Homogeneous because they look the same when you mix them. It doesn't look different. And heterogeneous because you see different phases. When you mix water and oil, you have two different phases where you can see the oil, where you can see the water. When you see more than two things after mixing, that's heterogeneous. When you mix tea in water, you only see the color water because of the tea, but you don't see the tea particles. You only see it looks the same throughout, homogeneous. Salt and water. When you mix salt in water, the salt dissolves in the water. You don't see the salt anymore. But it's a mixture. It's a homogeneous mixture because you only see one thing. If you can separate the substance that you have and obtain the materials or the substances you started with before mixing, that will make it a mixture. If you cannot break it apart, that will be a pure substance. So carbon monoxide, you can break down, but you cannot separate by physical means. Pure substances get separated by chemical means. Mixtures get separated by physical means. Just I'm giving you a flow chart to determine what is what. Can it be physically separated? No. Then it's a pure substance. Yes. Then it's a mixture. Does it look the same? It's homogeneous. Does it look different? Heterogeneous. It's a pure substance. If it is a pure substance, can it be chemically decomposed? No. It's an element. Yes. Compound. Remember, elements are the smallest you can divide matter. If you try to divide an element into a smaller thing, you lose the properties of that element. It's no longer matter. We don't look at that here. Okay, I know that these answers are in here, so I'm not going over those, but I'm going over these ones. Okay, we have a mixture of sawdust and sand. Will that be heterogeneous, homogeneous, a pure compound, or a pure element? It will be hetero because you can see the sawdust and the sand. A mixture of antifreeze and water. Yeah. It is a mixture, but I'm looking. Is it homogeneous or heterogeneous? Antifreeze, that stuff that you put in your car for the windshield. That blue liquid that you put in the car, or that yellow or green, it will be homogeneous. When if you add water to it, it will dilute. It will not look like anything different. It still looks blue or it still looks green. I'm sorry, I'm assuming you know all these things, but there's a couple more that I'm going to throw you off. Okay, so antifreeze is the stuff you put in the car. It comes in a color. When you add water, it doesn't change the color. It changes the color a little bit, but it's still blue or green or yellow. You're not gonna see the water once you mix them. So it's homogeneous. Okay, an iron chromium alloy. To answer that one, you need to know what an alloy is. What is an alloy? Yes. A compo Some metals combine together. They're usually melted together to get something new. So an iron chromium alloy will be no. It will be homogeneous mixture. Again, alloy, you're mixing two or more metals together. You're melting them together into one. You're making something new. You're making, let's say, brass. If the alloy is made correctly, you will get something new that looks homogeneous. You don't see the components of it. If it is an impure alloy, then you might see chunks of the different metals in it, and that will make it heterogeneous. But by nature, alloys should be homogeneous. Okay, a mushroom and onion pizza. Hetero. Okay, let's see if you get this one. Cough medicine that says shake well on label. I heard heterogeneous. Everybody agree with that? Okay. So it says shake well on label. It means you haven't shaken it yet. So it's hetero. For it to be homogeneous, I will have to say cough medicine that's been shaken. When you go to the pharmacy and you get your amoxicillin, that's an emulsion that comes with different things, and they add a liquid to it, and then before they give it to you, they shake it, and it either looks white or pink. At that point, it will be homogeneous. But before, when they mix them together and they haven't shaken it, it's heterogeneous. Okay, a gold nugget, pure element, a copper ore. You need to know what an ore is. It is heterogeneous. So an ore is when you go to a mine and you find a rock of copper. It has copper on it, but it has other things in it. And you can see all the things. So ores are heterogeneous mixtures. Okay. Aluminum foil. Homo- wait. Aluminum foil. So you have foil made of just aluminum. What is aluminum? An element. So aluminum foil is just element that been um, pushed into a foil. Just because it's in foil form doesn't mean that it's not an element. So it's still an element. Okay, pure water. It is a compound, but it's also a pure substance, but it's also homogeneous. All compounds are homogeneous by nature. All compounds are homogeneous by nature. Okay? The contents of a gas tank filled with nitrogen and oxygen. You have a tank, you put two gases in it. It will be homogeneous because you cannot see the nitrogen or the oxygen. You cannot see the gases. And the last one, you have a block of sodium metal. Sodium is an element. So a block of it is just an element. Don't read too much into the statements or you go crazy trying to figure out what they are. They're supposed to be straightforward things. Okay, let's see what's left. So you need to know all these definitions because from now on, I'm going to start talking about atoms, compounds, mixtures, and so on. And we don't have time to go over those definitions again. So next week, please bring your outlines for measurements. They're all on Canvas because we'll start using those. You need your calculator, scientific calculator, so we can start learning how to use the calculator in the chemistry setting. Just give me a couple of minutes. Don't forget your assignments for the weekend. If you took the lab with me on Monday already, don't forget you don't have a lab on Monday. You're free to go. The rest, I'll see you in the lab in a few minutes. No, eso es para ti. No, está bien. Me lo puedes devolver si quieres. Si no, te quedas con él. Ok, está bien. Sí, sí. Kevin, Kevin. Okay, thank you.